Here's something really cool. I'll go ahead and leave it up there for you. Uh, a fragment of the Campo del Cielo meteorite. It says here from Gran Chaco, Gualamba, Argentina. Anyways, it's a iron octahedrite, 3 millimeters IA. The first time it was found, well, other than the natives, was in 1576. This specimen weighs 22.9 grams, and it's been tumbled in a tumbler. But this fragment was found in 1988 with very little surface rust. But if you want to look at that, isn't that really cool? It's definitely something out of the ordinary. Can't make this in a lab. Isn't that incredible? I mean, sure, it's iron and nickel alloy, but in the patterns that are found in the interior structure, you can't design this in a lab. It takes a star to make something like this. And on that note, well, actually a little bit more on this. Here's another chunk. It says here the composition of the average meteorites is 92% iron. Then you have nickel and cobalt. As well, you have, see, what are the, oh, their compositions. Okay, there they are. There's a cobalt, and you have phosphorus and 87 parts per million of gallium, 407 parts per million of germanium, and 3.6 parts per million of iridium, and the rest being iron. And there are lots of different pieces. The mass, and when they were found, this is in tons, so these are very, very large specimens that have been found. I'm sure they're going to find more because the most recent one was 7.85 tons and found in 2006. I'm sure there's probably more. But on that note, oh yeah, you're going to have its actual location. Here's Argentina, and then that's where the meteorite was found. They were strewn about all over the place, so it was a very, very large object that broke up in that area. We should be happy to have been able to collect this stuff. And the theory I'm developing, it's very important to understand that, okay, you have Earth, and you have Mercury, and then you have, the layers. I don't think that there's a liquid middle core in Mercury, but it's liquid inside the Earth because Mercury doesn't have a magnetic field. I think it's mostly solid throughout. So this is up to interpretation. As well, you have a solid inner core and this isn't to scale. I mean, relative, I should say. This is more relative. You have Earth on the left, and then you have Mercury on the right. And if you notice, the cores are roughly the same thickness. So what that tells me is that at one point Mercury was probably as thick as the Earth in solid composition, not just with gases, but with solid composition. It also tells me that Mercury is really, 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 really old. It's probably many tens of billions of years old, maybe even hundreds of billions of years old. But of course, inside the Big Bang paradigm, that's not allowed. We all know better. Mercury is probably older than Earth by many hundreds of billions of years. Because look how much time it would have had to take for the surface to be excavated away. And the surface excavation is evidence of that. And on that note, we have the inner material. The inner material is iron, mostly iron and nickel, the same exact composition as this little piece right there. So imagine this is like a piece of the core. This is exactly what's in the center of the Earth. This stuff right here. You're looking at it. I'm holding it in my hands. It takes many billions of years for a star to evolve and form a core. And over time, when the star travels throughout the galaxy, it gets ripped to shreds by impacts and photoevaporation. Eventually, it'll start exposing the little core. And then if there's a big enough explosion, boom, it can excavate solid chunks like this, which then wander the galaxy and then enter into the atmospheres of other other older stars. And we can pick them up off the ground and, you know, look at them and study them. So essentially, when you hold an iron nickel meteorite or a stony iron meteorite, you're holding the core of an ancient dead star that's older than the Earth, that probably came from somewhere else in the galaxy entirely, if not an entirely different galaxy altogether. And that's what's so unreal about holding this in my hands. It's like you're holding extraterrestrial matter. And by extraterrestrial, I mean extragalactic matter. Remember, there are no walls separating the solar system from the other parts in the galaxy. There are no walls to make sure no extra material can come from somewhere else. But look at that. Isn't that incredible? But I just wanted to share that with you guys. You have a whole bunch of this stuff wandering the galaxy. And I suggest if you want to buy some of this stuff just to look at it. I was going to buy one of those pieces that was sliced and then, you know, polished and then acid etched so you could see the patterns. But, you know, this will do for now. I'll go ahead and purchase something like that later on when I get a little bit more money. But, yeah, this is a piece of a core of a black dwarf star, or a dead star. Alright, you guys, today is March 6th, no, March 7th, I believe now, 2016.